Okay, there we go, we're recording. So welcome again, everyone. I've tried to pitch this at a fairly, I guess, moderate level. So as a recap of what we're going to do, an explanation of what is a Bitcoin, what is a blockchain, the ecosystem of the blockchain, who does what, how it fits together. We'll see this in several different incarnations with our own simple blockchain currency we're going to build, a slightly more complicated one we're going to build after that, and then the context of Bitcoin. So the first demo is a web-based demo, so you can run that in your browsers. And then the second demo is the VM. So is everyone downloading the VM? If not, now is a good time to start. It's about 700 meg, and then you'll need to unzip it, and you will need VirtualBox from Oracle to execute it. If you don't have time or don't feel like doing that, so long as you have a Linux box which runs Python 3 and you're willing to install some pip packages, then you can do without the VM. Then we'll wrap up with any questions. And as a bonus exercise, you can build a full node for Bitcoin. I'll explain what this means as we go through the session with a Raspberry Pi. You'll need a Raspberry Pi 4 with at least 2 GB of RAM and also a 500 GB hard drive. So if anyone's interested, we can do that at the end. Why are we here? Because we all want to buy Lamborghinis with our Bitcoin, right? Hands up if you want to buy a Lamborghini with your Bitcoin.
Sure.
The cryptocurrency idea started just over 10 years ago with the publication of a paper by a mysterious person called Satoshi, who no one knows the identity of. Unfortunately, I cannot reveal it for you. And really, it was the nascence of the Bitcoin network. But Bitcoin isn't just a thing, it's a whole ecosystem. So there are many components and lots of moving parts and subcomponents which go together to build what is effectively a full financial network for cryptographically secured transactions. It may sound complicated and almost impenetrable, but in fact, anyone who has a computer, you can start to read the source code for it, compile your own wallets, and really kind of get stuck in. There's a lot of hype around Bitcoin, cryptocurrencies in general, and also the blockchain. And from what I've seen, anyone who is pitching blockchain as a solution to the world's problems, a solution to authenticity, to making sure that this organic cucumber that you're buying actually came from an organic farm, or that whatever is in a shipping container is really inside the shipping container, is overselling it. Realistically, the blockchain is just a new way of doing a database, and it's a technology which will have lots of uses, I'm sure, in the future. But for the moment, cryptocurrency is the predominant use of blockchain. So I hope that's my motivation in putting this together, to kind of dig a little deeper into this idea, and hopefully to share it with you. So what is a Bitcoin? Fundamentally, a Bitcoin is a cryptographic key pair. So Bitcoin consists of a public key, which is your address or your wallet name, which is what can be shared with everyone. And it says that this is an address on the Bitcoin network. And then the part when you hear about someone who had a USB key and it had 100 Bitcoins on it and it's now worth $5 million, and they threw it in the bin and it's in a landfill somewhere and they want to dig it out because it's worthwhile, what they're really talking about is their private keys. So without your private key, you can't sign transactions, so you can't access your Bitcoins. The whole idea came from this paper, which we can see on the left. You can download it and take a look if you want, which was published on 9th of January 2009, just kind of appearing onto the internet. It wasn't published at a conference or anything. And the identity of Satoshi Nakamoto is unknown. It's most likely a pseudonym because there is no Mr. Satoshi Nakamoto who is related to this. And there are many theories as to who were the original drivers behind making Bitcoin, whether it was intelligence agencies or anarchists. No one really knows. It's interesting to speculate, but this paper really kind of sets out the entire structure and the groundwork for building Bitcoin. But Bitcoin as a network for transactions is built upon a lot of existing computer technologies which exist, of course, the internet. But the most fundamental piece really is public key cryptography. Is everyone familiar with this concept? You could kind of give an indication, yes or no. If everyone already knows what this is, then we can.
Not much, really. Just
okay. So I'll try and explain it as best I can. The idea of public key cryptography is that you want to receive secure messages over an insecure channel. So if we put something on the internet, then anyone can download it. Who knows where it's going to end up and what's going to happen to it. So let's say that I want to communicate with my family, and they're in the UK, over the internet in a public forum. But I want to do it in such a way that only I can read the messages. So we can use a system called public key cryptography. And this basically revolves around two pieces. So the public key and the private key. It's called the public key because I can log onto an internet message forum and I can post my public key. And I can say to my family, go to this URL, download my public key. What they can then do is with a copy of that, they can write the message and they can use it to encrypt it. So then we end up with an encrypted message, which is what we have in the middle of our slide here. And the only person who can read it is either someone with a very powerful computer. Sorry, that's my Alexa, which is talking even though it's muted. So you have this message and you need a private key to decrypt it. So the private key I have for me, and I keep it safe at home on a flash drive or on my computer, and I don't share the private key. And with these two key pairs, we can communicate almost indefinitely by the sender encrypting the message. And of course, the sender can also send me a public key. So with public key cryptography, we can do bidirectional communication. And this works so long as our algorithm that we use is secure. So it's independent. There are many algorithms which you can use to do this type of cryptography. And it works in both directions. Of course, it falls down if I either divulge my private key. So if my private key leaks and I accidentally publish that on the internet, then anyone can read my messages. Or if I lose my private key, which is what happens when people lose their Bitcoin, then all of the messages that have been sent to me, I can no longer decrypt them. So that is a very simple functional explanation of what public key cryptography is. And as you'll see, this is really the fundamental piece that underlies Bitcoin and blockchain technologies, in that we have a ledger, and the blockchain, consists basically of public keys, many different public keys for all the people who are involved and for all of the wallets that people use. And then there's the private part, which is the recipient's private key, which is your Bitcoin, if you will, that you keep for you. And if you lose it or it leaks or it gets stolen, so this is what happens typically with Bitcoin, is that people try and steal these private keys, because then they can impersonate the owner. And when the money is spent, there are no more Bitcoins left. So this graphic I got from the link below. There's a more detailed explanation of public key cryptography on there. Does anyone have any questions on public key cryptography? Okay.
Was clear, thanks.
Sure. So was that a question or? Okay, let's move on. So the next So that's kind of the basis for all of this. The next thing is blockchain. So you've probably heard about blockchain in the news, on the TV, on the radio, everywhere, all over the internet. Blockchain is the new black. It's a very popular term. People are saying that it will solve all of our problems. But what actually is a blockchain? At a fundamental level, a blockchain is a database. So it is a sequence of blocks, and each block contains information. Here is from the original Satoshi paper what the Bitcoin blockchain resembles. So we have two kind of fundamental parts, and then we have some baggage which is attached to it. So we have a hash. So a hash function is a mathematical equation which takes in, typically it's used for hashing files. So if you downloaded something from an internet server where they say, here is the MD5 hash or the SHA hash, it's a way of authenticating the content of a file that you've downloaded. So a hash function looks at all the bits in an entire file and comes out with a number. And that number is called the hash of the file. And whether that's a file, that can also be the hash of a number. So what we're looking at here is hashes of numbers. And those numbers are called the nonce, N-O-N-C-E. And this is basically, it's a special number. And when we hash it, it gives us a particular value. We'll see this when we do our example. So we might say we only want hashes as an output that begin with 3 leading zeros. So we need to iterate through numbers until we get 1, which will give us a hash with 3 zeros. And then we can consider that to be okay. And the number which gave us that hash would be the nonce. So we put those two things into our block. And then the next block which is made, we use as the starting point that number. So maybe we're incrementing, so we're going up through all the numbers, and when we find one which gives us the right hash, put that in the block. And then the next person who is mining a block takes that number and just increments, tests it, increments, tests it, and they need to increment it maybe 1 million times, maybe 100 million times in order to find the next hash, which has 3 zeros. Hash functions are designed to have a fairly low number of what are called collisions. So that is the same numbers. So let's say if I take we make a hash function and I give it the number 5, and the hash of 5, let's say, is 1. I then give it the hash of 6, and the output might be 3,200,000. So there is a wildly varying relationship. It's so complex that we can't easily predict, oh, well, if I want a hash of X, then I should input Y. It's not deterministic in that way that we can solve with computers we have today. So it's very much, it's a trial and error process, and it's computationally intensive, which leads us on to our next concept we'll talk about in a minute, which is called a proof of work. The other thing you'll see in the block is TX. So TX in this case represents transactions. So you'll hear people talk about wallets in Bitcoin as the idea that you have your wallet and you store your money in it. In fact, this is a bit of a misnomer, and the money that you have in Bitcoin is associated with addresses, but actually all of it lives in the blockchain. So if anyone, does anyone here in the audience own any Bitcoin?
No.
Okay.
No, neither me.
I own, I think, like 0.02 Bitcoin, but I bought it through a financial product, so I don't actually have to handle the cryptographic keys myself. So anyone who does own Bitcoin, basically there is a transaction within the blockchain, and you are the owner of the public key, and your public key is in the blockchain saying, this address, X many Bitcoin received from someone who created the Bitcoin in the first place, if you bought it. And in the future, when you say you want to spend that Bitcoin by transferring it to somebody else, then what you do is actually you say, you reference, my Bitcoin address was used at this time and someone paid me a Bitcoin, and now I reference that transaction and pay that Bitcoin to somebody else. So the kind of the credit that you have lives on the blockchain, but it's not like a conventional bank account where you can go and look and say, right now I have 500 Bitcoin in my account. It's more that actually there are maybe 30 transactions in the blockchain, and those contain, if we sum them all up, the amount of Bitcoin that I own. And the only way we can do this is by looking recursively. So we need to go right back down the blockchain to whenever it was that we acquired our Bitcoin and look at every single block and every single transaction. The other thing that you'll see is that there are multiple TXs in each of the blocks. So one of the ways in which you can make money from Bitcoin, if you are mining Bitcoin, is by charging people a premium in order to include transactions in a block that you have just mined. So typically, as someone who wants to transact Bitcoin, you have to put a little premium on your transaction to say 0.001 Bitcoin. The minor unit of a Bitcoin, for interest, is called a Satoshi, in the same way that you would have pounds and pence. The pence part of a Bitcoin is a Satoshi in honor of the founder, who may or may not be real. So you pay a little premium, and that enables miners, so people who are making the blocks, who find the numbers, they receive that premium in exchange for their work. They also, at the moment, get rewarded with Bitcoins. So at the moment, I think if you find the next hash, then you get 4 Bitcoins. And every 4 years, there's what's called the halving. So the amount of Bitcoins you get for finding the hash is reduced by a factor of 2. This is as a compensation for Moore's law, with computer power increasing exponentially. The idea is that the rate of production of Bitcoin should be more or less constant in time up until all of the Bitcoins are made. And this is done by making the algorithm more difficult and by reducing the amount of Bitcoins you reward people with each time they find a good hash, so that there is not a surplus of supply. One of the big questions that I asked myself when I started putting this together is, what happens when all the Bitcoins are mined? So for those who don't know, the Bitcoin algorithm fixes the maximum number of Bitcoins that will ever be made at 21 million. When we reach 21 million Bitcoins, the algorithm says, stop, the end, no more new Bitcoins are produced. What happens next? How do we transact? If no one is producing Bitcoins, how do we transact Bitcoins? What's going to happen to the network? And this is where this premium that people pay in order to have transactions included in the blockchain comes into play. So it's estimated that we will run out of Bitcoin in 2040. And when the last Bitcoin is mined, I'm sure a lot of people will stop mining, but some people will continue to mine because of this premium. So when you, in 2041, when all the Bitcoin are already produced, if you're a miner and you're still producing these hashes, you will receive a premium from people who want their transaction added to the blockchain as an incentive for you to mine. So that will compensate the energy, electricity, and also the computer infrastructure you needed to buy in order to do the mining. As of today, this is a very, very small amount of money, but with the value of Bitcoin increasing, the premium, even the smallest unit of Bitcoin is worth more. So the premium to miners is increasing. So this is kind of how one block, each of the blocks of the blockchain comprises transactions. Of course, it's a digital construct. So in fact, you can put anything in. So there are people who have paid, artists who've paid to have works added to the blockchain by including it in this process. So you put it into the Bitcoin network and you say, I will pay anyone who can add this to the blockchain 0.01 Bitcoins. And the next time a coin is mined, then a block is added and your piece will go into it, and including a transaction that gives your Bitcoin to the person who added it for you. And then it's mirrored on all of the Bitcoin nodes across the world, and it's impossible to delete it. more or less. This has advantages and disadvantages. And given that the nature of some people who use Bitcoin, there are, I believe there are some viruses embedded in the blockchain already. Of course, it's no problem if you just keep the blockchain, but if you were to extract them and turn them into executable code and run them, then this could be a problem. So that's the blockchain. And I mentioned earlier, we have this concept of a proof of work. So what is a proof of work? A proof of work can be anything. Here, it's a computationally intensive task. So it's something which is non-trivial. It's not 1 + 1. It's give me an MD5 hash that has 5 leading zeros for a number greater than 1 million. It exists for its own sake. So it's not useful. It's not like SETI at home or the LHC at home. We are not solving the world's problems by doing our proof of work. Really what we're doing with a proof of work is literally just burning electricity and making our computer run in order to get the answer to a relatively difficult mathematical problem, which has no benefit to anyone in the world other than it is difficult. So there is no benefit in itself of having a proof of work. The proof of work here, so this is the hash function. The hash that you have to generate to make a block of Bitcoin is this proof of work element. And when people are mining Bitcoins, what they're doing is they're executing this proof of work in order to find the hash number, to find the nonce number, which then they can use to make the next block. This acts as a barrier to entry. So in order to make a proof of work, these days I need a custom ASIC. Back when Bitcoin first started, you could mine coins on your CPU, on your desktop computer, on a spare laptop, and you would generate some coins over a period of days and weeks. Then, because the Bitcoin algorithm gets more intensive as time goes on, the first era of using a CPU finished, and we moved to the next era where people would use GPUs. The massive parallel structure of the GPU processor is fairly well suited to doing the kind of parallel computation you need for the Bitcoin and other cryptocurrency proof of work. So that was, for a time, a very popular and powerful way of doing it. Again, you need a lot of electricity to power high-end graphics cards and to keep them running at 100% all the time. Today, we are more into the era of ASIC. So ASIC stands for Application-Specific Integrated Circuit, and it's a custom bit of silicon, which is designed exclusively to run the Bitcoin algorithm, to do the Bitcoin proof of work. And that, when you feed it with electricity and the previous blocks, it will eventually generate you new nonces, and you can make new hashes and new blocks. And if you were to look at who is making the Bitcoin supply in the world right now, you'd find that it is predominantly people in countries with cheap electricity, regions of Russia, China, using big barns or buildings full of custom silicon ASIC miners. Antminer is, I think, the predominant brand, but many people have different ASIC solutions. And if you want to buy yourself an ASIC block, an Antminer will typically set you back a couple of $1,000, and that is just for the hardware. And then you need to bring that hardware somewhere and plug it in, and it's probably going to run at a kilowatt. So it'll use a lot of electricity over the course of a year, and you will be competing to find the correct nonce value against people with huge resources and massive farms. So unfortunately, kind of one of the problems with Bitcoin as the victim of its own success is that it's not really economic anymore to mine your own Bitcoin, certainly with the electricity prices we have in Switzerland. Another way to think about the proof of work is as a potential solution to the problem of spam email. So people send junk mail. Here I have some junk mail that I received, and it cost the company that produces the mail obviously money to print, and money to distribute. And they do a sum and they say, okay, we think that in terms of marketing, it's worth us spending 1 Swiss franc per customer per month sending out junk mail in order to bring in business. This cost, of course, doesn't exist for email, which is why all of us probably get at least 200 spam messages a day. Fortunately, most of them are filtered out by artificial intelligence, but still, I mean, I get quite a few that make it into my inbox. This is because there is no barrier to entry. There is basically a zero cost to sending an email. So one example of how you could apply proof of work is if you say, right, in order to send an email, now you need to do an MD5 hash that has 3 leading zeros, and you need to publish that. And so I will only accept an email that comes with a fresh MD5 hash every time. And if we did that, then that would kill off spam mail pretty quickly. The disadvantage is that every time you want to make a new message, that we would have to pay this tax. It's effectively introducing a postage fee. So it's probably not a great idea, but it's another way of looking at what is a proof of work. It's basically a barrier to entry through complexity. So now let's try a simple demo. So this is a web-based blockchain simulation where we can look at the idea of proof of work, how a blockchain is built, how we have different peers in the network. So you can go to blockchaindemo.io, and hopefully this is going to. Just thinking.
Oh.
It's my dinner time. Thank you, Alexa. Alexa, computer, dismiss. Sorry. Okay. So here is our blockchain simulator. So what we have here is our Genesis block. If you download the entire Bitcoin blockchain, you'll find that the very first block is called the Genesis block. So this is the first hash from which we seed all of our subsequent hashes and we construct our blockchain. And it doesn't really matter what it is per se, it's just that we need one, and it needs to be unambiguous in order for the blockchain to get some data. So we'll add a message test, and we'll add a new block. And we found that we can read this hash, and we have the new hash. So you see we have 3 leading zeros here. This is the proof of work element, in that not all hashes have 3 leading zeros. And so we made our first blockchain. This is block 2. I have a transaction. So if we have a transaction, add that. So now we press it, the JavaScript is doing the hashes, and we go and add 3 leading zeros. So this is built on the previous block. Okay. So it's a sequential function, and this is a simplified analogy of how Bitcoin works. Okay. The other thing we can do is we can add peers. So we have different people within our network. So now Satoshi is this one, and Satoshi has made these blocks, but Aki is our second person. So now we connect Aki with a little plus to our blockchain, and Aki now the whole blockchain, and we'll next block. So there we go. Again, we still have this direct hash function, which shows that the proof of work is done. And we can go back to Satoshi. Now, when Satoshi looks at the blockchain, he sees all 3 of the blocks. Is that a fairly simple overview? Does that make sense to people? Any questions? Okay. So feeds help just keep block, and we can also keep adding people to our network and peers and so forth. So now we have Marco, and Marco just after the Genesis, we can look into the network. One of the other things, we won't mention it now because it takes a little while, but this idea of a universal source of truth. So of course we can have Marco come in, and if Marco doesn't download all the existing blocks, let's say he only has up to block 2, and there's someone else made a block 3, Marco can start adding to the blockchain thinking that block 2 is the most recent block, and he's wrong. Bitcoin has a mechanism for resolving this by voting. So if you run a full node and you keep the whole blockchain, what happens is it's a majority vote. So the strain of the blockchain that has the most recent blocks predominates. If you own the majority mining pool, then the ones which you choose to accept predominate among the blockchain, and the other copies of the blockchain which have effectively a mistake in them will disappear over time because they will not be accepted by other nodes on the network, and so we'll have to go back to the most recent common point and restart constructing the blockchain. So let's minimize that simple demo. So there we've covered an example of proof of work, blockchain, and how peers can share the blockchain and then add to it. Okay, I highly recommend this link down here, Free Code Camp. It gives you some more background on the hash function that's used in this case and how it's structured. So what we're doing here is we start from our Genesis block, we do a proof of work, so that's why there's a delay when we push the button. We add it to the blockchain, it's distributed to the peers, and we repeat it. And this is fundamentally the loop of Bitcoin and all other blockchain-based cryptocurrencies, where someone's doing a proof of work, they add it to the blockchain, it's distributed, and it's repeated and repeated and repeated. And for Bitcoin, this process happens every 10 minutes. So every 10 minutes of the day, because of the way the algorithm is structured, a new block is added to the blockchain, and any transactions can be included in that block and processed. Okay, so let's move on to the VM example. Has everyone been able to download the VM and uncompress it?
Yes.
Yes.
Okay.
Unfortunately, no, because I can follow as far as you explain things. It's fine.
Mm-hmm. Sure. So I'll run the VM. So I've got my crypto webinar VM. The credentials are here. Maybe it's so the root password is Bitcoin HODL. That's H0DL, and the user which is credentialed in is called Crypto, CRYPTO, and the password is Bitcoin Lambo, so LAMB0. Okay. Let's start. VM. So I configured this as a minimal VM. It only has 512 meg of RAM, but it's enough for our purposes.
James, while we are waiting for that, do you intend to cover a little bit the logic economically speaking, or this is out of the scope?
For me, I was just going to focus on the technical part of it today.
Okay.
The kind of the underlying process and the different pieces of the network. I'm afraid
so is the pure technical generation of Bitcoins, right?
Exactly, just the hardware.
Okay, thanks.
One thing which, for me, I find quite interesting. So I built a full node for the Bitcoin blockchain, and I've had it running in my house on an old network-attached storage server that I've repurposed. And it's been running, for about a month now. So it keeps I have a copy of the full blockchain ledger for Bitcoin in my house. It's like 380 gig on a 1 terabyte hard disk. And what is quite interesting to me is that it is completely separated from the economic value of Bitcoin. So what this ledger has is just all the transactions. It has no reference point at any interval to how much a Bitcoin is worth in dollars or euros or Swiss francs. That is a completely separate market function. So that's kind of the basis for this talk. Is like we're going to talk about the technical piece for now, and how the market part of it works. I'm afraid I need to update myself. So here's our VM. It's finally come up. So this is a standard Debian stretch VM without the graphical desktop environment. And what you'll find when you're logged in is that I have already downloaded for you the Simplecoin. So Simplecoin is a blockchain system with wallets written in Python. So it's nice and easily accessible. And this will enable us to go kind of the next stage into our blockchain journey, where we can create our own wallet, and we can have a miner which will put coins into our wallet, and we can see that the value of our wallet grow. Right, VM is coming up. So in the meantime, I have just opened a putty session. What I'm going to do is run the miner on the VM, and then I'm going to SSH in to look at my wallet, so I can see my wallet filling up as we go along. What I've done in terms of network settings is just to enable port 22, so I can have a putty session. So I can connect from my desktop. Right, so if you want to enable port forwarding, you go to Network, Advanced, Port Forward. And here, so I've just added rule 1, TCP 127.0.0.1, which is the local host, 22, and then guest IP 0.0.0 for any IP, again to port 22. So you need to have this line added and enabled before you can SSH in remotely. Right, okay, still booting. This is slowly. Here we go. Right, so now I'm going to log in as crypto. And I put in the password, Bitcoin, Lambo. And we should have the user prompt come up in a second. So you'll see that there's a directory called Simplecoin. So I've already downloaded from GitHub the Simplecoin repo, and we can go to the Simplecoin directory where we have our Python scripts. So there are 3 scripts here, the miner config, and the wallet. The first thing we're going to do is we're going to run the wallet. So Python 3 wallet. And this gives us the option to generate a new wallet. Okay, so we want to do that. Okay, so write the name of your new address. So I'm going to call it Lambo. Okay. And now what it's done is it's created a text file called Lambo, which we can see here. I'll just cap that for you. So very simple. We have our private key and our wallet address and public key. Okay, so going back to the public key cryptography, so this is the same elements that you would have for your Bitcoin wallet in this format. Now, what I need to do is now we need to configure our miner so that it will mine coins and put them in our Bitcoin wallet. Otherwise, there's no point in doing the mining. So now I'm going to connect my putty. Okay, so this is the second session to the same machine. Also log in as crypto. Okay, and so then we have our text files as well. And actually I'm going to cat it here because it's easier for me to copy it. So what I'm copying is my wallet address. Okay, so I was looking for a slash in the wallet address, which is what I had when I did this. But yeah, that's this. So to run the miner, let's try this right. I'm going to do Python 3 miner.py. Okay, so you see the simple coin blockchain system, development server, and it's running. And there we go. It's found its first block and another block. So what you can see, annotate. We have the proof of work and the proof of work number comes up there. We have an amount. We have the hash. So these are all the basic ingredients. And then the other thing you can see is to. So this is where the money is going to, which is our random miner address. Okay, which is not a real address, so it's just disappearing. So what I'm going to do now is close the kill that process, and I'm going to copy the public key. Oops. Let's try again and make a new wallet. So for example, if we check our transactions, it fails because we don't have a running miner. Second wallet, retry. So now we can that, okay. Let's do the same here. So what I'm going to do is copy my public key. And now I'm going to edit the miner text file. So if we do miner config, this is the configuration file for our miner. And here we put in our address. The clipboard is not shared, sorry. Just going to do the same thing. In our party session. So here we go. Okay. So now we've put our miner address in. Save that. And now our miner is configured to put coins in our wallet. So we shall now run the miner again. And now you'll see that the to address has the public key. So you can see our public key on the left. Here was 1 MAQ, and now our miner is putting coins into that wallet, 1 MAQJ. Okay, so this simulates how a normal Bitcoin miner would work. And now we can check our balance in real time. Connecting back in. So we want to check our transactions. And now we can see the same transactions here that we have in from our miner. So at the time when we pressed this, we had index 0, index 1, 2, 3. So we had 4 of our virtual coins generated and sitting in this wallet. Because, like I said, the wallet itself is really just an address. And what this wallet Python script is doing is it's looking at the blockchain that we're making, and it's going back through every single block and saying, how many Bitcoins are there for this address within this block? And the sum total of that gives our balance of how many coins or pieces of coin we have. So we've mined another few coins here. Obviously, this is running a bit slowly in the VM. It's fairly restricted. So if we run our wallet again, previously we had 4 coins. And if we check it again, now we are up to next 4. Yeah, we're up to more coins, several additional ones. So that shows you how when we find a hash with our miner, it gets credited to our account. And I think the final thing we can do, so we created the first wallet, which we call Lambo. So now we can transfer some money from one of our wallets to the other wallet. To do this, I'm going to create another party session, just so I can copy out the public key. So we're going to send coins to another wallet. So introduce your wallet address. So here, this is our wallet where we've been putting the money. Okay, and now we need to put in our private key. So we are on retry. So here we have our private key. So we shall copy this. Okay. And now we need to give our destination wallet address. So we will now the address from the Lambo wallet, which is here. Copy that. How much do you want to send? So we shall send 1. Yes. And now you'll see that it waits. Why is it waiting? It's waiting because we can't do a transaction until we've generated a new hash, because it goes onto the new hash. And here you can see the new hash, the new block that we added includes this transaction. So a payment from 1 MAQ to DZ8. And let's just go back and look at what is our public address for our second wallet. It is DZ8. So there we go. We've generated a coin and we've transacted it. And the transaction is successful. So I think that concludes the demo portion of this talk. Does anyone have any questions? Has everyone been able to replicate this and make their own virtual transactions at home? I hope so.
The good news is that we can reuse your recording just to try to follow the steps again.
Yes.
So.
Okay, so that kind of shows you the two components, and the Bitcoin architecture is the same as this, in that you have miners and you have wallets. A full node is basically a wallet, and a miner is a hash generating machine. So I don't know if anyone is interested in kind of the additional bonus activity. If you have a spare Raspberry Pi, so you can do what I did earlier this year, end of last year, is you can create your own Bitcoin wallet, which is a full node, so you have a full copy of the blockchain. It's, I should say, not very computationally intensive. So you can take your Raspberry Pi, you can compile from source the Bitcoin code, which is built for ARM64 or ARM32. And then you will have a full copy of the blockchain, which is effectively the source of truth for the network. So if you want to see a particular transaction, you can look at it on your server. And between you and all the other servers, there are about 10,000 full node Bitcoin servers like the one that I put together running on the network right now, which together form this source of collective truth for what is the current Bitcoin hash and all of the transactions that have taken place. Of course, it doesn't generate you any revenue. I don't get any money from it. But with the minor investment in Bitcoin, that more than covers the electricity, the way it's going up at the moment. I could store my Bitcoin on the server with my wallet, just like we have in our example. But it's not a very good idea from a security point of view, because this is a machine that's always connected to the internet. And the Bitcoin node has been targeted in the past by DDoS attacks. So best to keep it separately. And as I say, it's really not computationally intensive. You can run it on a Raspberry Pi 4 with 2 GB of RAM and a 500 GB external hard drive. Right now, the size of the Bitcoin blockchain totally is about 370 gigabytes, give or take. So that includes every single transaction that's happened since 2009, plus anything that people have paid to have added to the blockchain. And there's a really nice tutorial here, which is the one that I follow, that takes you through the detailed stages of this. And of course, if you want to, if you have any questions about it, please feel free to get in touch with me. And I hope you've enjoyed it today. Does anyone have any final questions?
Do you allow me one? Sorry, somebody saying? Do you allow me one, James? On
Of course, yeah.
Strictly speaking, I mean, it's very simple to be put very simple. This is costing real money, which is the electricity, right? So exactly. Is there any correlation in understanding when it is worth to generate Bitcoins or not? You see what I mean? I mean, is there any easy mapping?
So at the moment, no. And the reason for that is because of the price of a Bitcoin. Of course, the price of a Bitcoin is what anyone will pay for it at a given moment in time. The issue is that even though you hear about it 24/7. It's all over Twitter. It's all over the media. The market size and the number of people trading and exchanging Bitcoins is actually still relatively small in the grand scheme of things. It's nothing on the US dollar or the euro or the Swiss franc as a medium of exchange. The issue with that is that the liquidity of exchanges, so basically financial exchanges where you can come with your Bitcoin and exchange it for money, or come with your money and exchange it for Bitcoin, they're all still relatively small, relatively immature, and there can be a variance in prices for how much a Bitcoin will fetch on one exchange relative to another exchange. They're all run by private companies. So there is a universal source of truth for what the Bitcoin blockchain is, and who has a Bitcoin, which addresses it belongs to, but there isn't a universal source of truth for how much a Bitcoin is worth at any given moment in time. They probably diverge by $3, $4, $5 from one exchange to the next. More kind of generally, yes, it would be entirely possible to write a little Python script that says, let's take 5 exchanges. What is the average Bitcoin price? How much electricity does it take? How computationally intensive is it? Should I mine? Yes or no? In reality, it's basically run by people who have the infrastructure, because these days, to be competitive, you need ASICs. The amount of processing you need to do versus the processing efficiency, you can't beat the ASIC holders. If you want to buy an ASIC, because it's at least $2,000 per box, you need a lot of boxes. So it has a high fixed cost these days. It didn't used to, but the fixed cost predominates, and generally mining is a fairly variable business in terms of coin price, electricity price, hardware price, need to upgrade your hardware. So I wouldn't recommend going into the mining business with ASICs unless you have money to burn. Oh, I see there are some messages in the chat. Pseudo-random generator. I don't know.
I made that because I didn't want to interrupt you. I made that remark as I was comparing the way this hashing mechanism works. I was wondering if it would be like the pseudo random number generator in the Monte Carlo universe.
Not really. The idea of the hash function is to converge on a single solution rather than have a distribution. It's almost the complete opposite. The idea for a hash function is to take. I mean, yes, you have kind of the hash should be random, but you're looking for order in it. So it's not a great explanation. I think there's, as far as I'm aware, there's not really much in common between hash functions and random number generators. Okay. Thank you, Michael, for the power consumption. That's interesting. And what is a hardware wallet? So I mentioned that you can, if you have a Bitcoin full node, you can store your Bitcoin on that machine. Because your private key, so we have, and let's go back to putting up a private key on the screen. Here we go. So this is our private key here. The CPU has overloaded in our VM. Anyway, so here's our private key. Obviously, we want to keep this secure. So basically, what a hardware wallet is a means of keeping your private key secure. It's a USB key with some protection on it, and what you can do is you can encrypt your private key in order to make sure that no one can steal it. So fundamentally, a hardware wallet typically handles that for you in hardware. Let's close that down. So, okay, I hope that answered the question. Right. Thanks everyone for attending. And,
Thank you for the presentation.